Hi, everyone, and thank you for joining us today for this webinar. Jason Allen here, the Concrete Pipe Guy. I am the Technical Resource Engineer for Oldcastle Infrastructure, and I will be presenting today's webinar. Our topic is Crime Scene Investigation, Pipe Inspection. So before we begin, I want to tell you a little bit about myself. I currently live in Utah, and I'm a proud University of Utah graduate with bachelor's and master's degree in civil engineering with an emphasis on water resource engineering. I've been in the civil engineering industry for over 20 years now. And when I was 18 years old, I started working as a surveyor and then transitioned into drafting and design in land development. After that, I then worked in the public sector as a county engineer and public works director. I've also done consulting design for the Department of Transportation and large municipal projects, mostly focusing in roadway and drainage design. Now I am a technical resource or marketing engineer for Oldcastle Infrastructure. So some of you may not be familiar with Oldcastle Infrastructure, so I'm going to quickly share some of the solutions that we can provide. As I mentioned before, I currently live in Utah, and I spend a majority of my time providing technical resources to design engineers, contractors, and inspectors in the Mountain West area. Most people know us by our precast products, mainly reinforced concrete pipe and precast box culverts. We also provide precast manholes, catch basins, among other things. Now, while this has been our main focus for many years, we have added some really cool new product lines to help meet your needs. Now, our newest addition in the Utah market is gasketed box culverts. So instead of the typical soil-type mastic joints, we now have the ability to manufacture gasketed box culverts and provide a watertight joint without any additional joint treatment, which saves time and money during installation. Oldcastle recently acquired Torrent Resources, which is a company out of California, and it is the industry leader in dry well manufacturing and installation. We've also expanded our stormwater solutions to include storm capture, which is a total stormwater management system that uses precast sections for underground detention storage. This system uses the strength of reinforced concrete to provide more volume for storage, which drastically reduces the footprint compared to other underground detention systems. We also have multiple stormwater treatment system options like sediment traps or hydrodynamic separators that can fit your specific needs and stormwater treatment requirements. Now, in a previous webinar, we discussed the basics of post-installation inspection, or PII. We also discussed the different specifications, including ASTM C1840, that explains the acceptance criteria for pipes after they have been installed. Now, if you watch these previous webinars, you're pretty much an expert in pipe inspection, what is acceptable and what is not. Now, in this webinar, we're going to put your knowledge to the test. We're going to use the information from previous webinars to identify issues from some actual pipe inspection footage. Okay, gumshoes, let's put on our detective hats and get to work. So the first case we're going to examine is a very curious issue here. Contractor called and said that he watched the inspection video and he noticed that there's a circumferential crack in a few different pieces of pipe right in a row. The contractor said that it's obvious that there is an issue with your pipe, and he wants to know what you're going to do about it as the manufacturer. Now, let's start by looking at the inspection report and see where these issues are. So as we pull up the inspection report, we notice that there are circumferential cracks at 5 different locations, one at 22.1 feet, one at 30.2 feet, 38.1 feet, 45.8 feet, and 54.0 feet. So let's go ahead and look at the video to see what the severity of the cracks are, see if there's going to be any major issues here.
And at 22.1 feet, as you can see, we have a crack that goes all the way around the pipe.
All right, so let's look at some observations here of what we can document from that video and what we know going in. So we know that this is an 18-inch RCP. And from the video, we could tell that these cracks are minor or hairline. It occurred in 5 different pipes in a row. And the first crack is in the middle of one of the pipes. Okay. So one thing that I always like to look at when I'm looking at the inspection report is, are there any patterns or anything that I can see? Now, one thing that jumps out at me when I look at this, and it's the first thing I always look for when we're dealing with a lot of circumferential cracks in a pipe, is what is the frequency? What is the space between them? Because we know that a stick of pipe is about 8 feet long. So we want to see if there's any patterns that come through here. So the first thing I notice is from 22 to 30 feet, that's 8 feet. From 30 to 38 feet, about another 8 feet. From 38 to 46 feet, that's about 8 feet. And from 46 to 52 feet, That's another 8 feet. So it's like every single 8 feet. Kind of interesting there. All right. So we first need to ask ourselves, are these cracks acceptable? So I'm going to give you a couple of seconds to answer among yourselves. All right, if you said yes, that these pipes or these cracks are acceptable, then you are correct. These cracks are hairline and thus are within the tolerances in the specifications. But you know what? I'm not satisfied stopping there. We're better than this. We're going to take it even one step further. In order to best serve our clients and our customers, we need to ask ourselves, what is causing these cracks? If it is a manufacturing issue, like the contractor wants to believe it is, then we want to resolve that. We want to make sure that we fix it. However, if it is an installation issue, then we want to help the contractor understand what they're doing incorrectly so that they don't make the same mistake in the future. So let's look at what we know. All right. Number one, we know that there's multiple circumferential cracks. We know that they're happening right in the middle of the pipe. We know that it's 5 pieces of pipe right in a row. And some of the things, that's what we can learn from the video. But what do we know about concrete and concrete pipe? Well, first, we know that concrete is really bad in tension and really good in compression. We also know that reinforced concrete pipe is designed to be supported on the barrels of the pipe. And let me show you what I mean by that. Here's a little diagram here that shows the pipe being supported on the barrels. So we, as the contractor digs these bell holes, we're able to set the pipe right down on the barrel of the pipe on the ground. So as we load the top of this pipe, it's being held by the barrel of the pipe. So it works as intended. Now, what we don't want to do is support it on the bells, because what happens when we support the pipe on the bells, instead of having the full use of that structural steel inside the pipe, we've basically just created a beam every 8 feet. Right. So we have this simply supported beam that when we load it, we create this high tension zone right in the middle of the pipe. And what does it want to do? It wants to shear when it goes in tension, when a beam does that. And because we know that concrete's bad in tension, we start seeing cracks right in the middle of the pipe. So now that we've looked at that, what is causing the cracks? So I'm going to give you a couple of seconds to answer the question. What is causing the cracks? If you said that the pipe isn't supported on the barrel, you'd be correct. Now, what happened is the contractor likely didn't dig bell holes, or maybe dug bell holes, but didn't dig them deep enough so that it was still slightly supported on the bell itself. So that is likely what's happening, because it's every 8 feet and it's right in the middle of the pipe. So the evidence in this case is pretty concrete. So just imagine that I'm like putting my sunglasses on, obviously, when I say that. But anyway, okay, Inspector, moving on here. While we're investigating circumferential cracks, let's look at another case involving a crack near a catch basin. This is actually really common. I see this a lot in videos when we're looking at it. So let's go right to the video and let's look, and I'll show you what I'm talking about here.
Looks like a little circular crack here, pretty minor.
Right, again, let's make our observations. Let's write them all down. This is an 18-inch reinforced concrete pipe. The crack itself is somewhere between 1/100 of an inch and 5/100 of an inch, based on what I could tell in the video. And this is, if you were to watch the whole video, and I didn't show you the whole video to save time, but if you watch the video, this is the only crack in the run of pipe. So it was actually a pretty dang good installation. No issues along the whole run of pipe. This was it. This was the only crack. All right. And it happened very near the connection of the box. So within a few feet of the connection to the catch basin and to the box. So again, let's first ask ourselves, is this crack acceptable? I'll give you a couple of seconds to answer the question, yes or no. All right, if you said yes, then you are correct. ASTM C1840 says that any circumferential crack that's less than 0.10 inches or a tenth of an inch is acceptable. But again, I'm not satisfied with that, and you shouldn't be either. Let's not stop there. Let's take it one step further, detective. What's causing this crack? All right, think about it for a second. What could possibly cause this circumferential crack to happen? If you said poor compaction around the box, you would be correct. Now, one of two things is happening, and that is if we weren't able to compact around the box or under the pipe and it didn't have a good bedding under it, either the box, the catch basin, is settling, or the pipe itself is settling. And either way, where we've got that rigid connection to the box with the pipe, and as one or the other settles and the other one is rigid and in place, it's not able to move. We cause this severe stress on the pipe, which causes it to shear and create a circumferential crack. So that is what's causing this. Again, imagine that I have my sunglasses in my hand right now. It looks like this case is all boxed up. All right, let's look at another case here. So what happens if we have the same situation in case number 2, but the structure itself, that box, that catch basin, or that manhole, whatever the structure is that the pipe's tying into, what happens if it settles like more than a little bit, like a lot of settlement, and the circumferential crack is more severe? Here, let's just watch the video and I'll show you what I'm talking about. All right, what did we observe? This is actually a 24-inch reinforced concrete pipe. The crack, if you could look in the video and tell, it's most likely over 0.10 inches or a tenth of an inch in a couple of spots there. It's a pretty severe crack, right? Again, this is the only crack in the run of pipe, and it's very near the connection box within a couple of feet. So again, let's ask ourselves, is the crack acceptable? Give you a couple of seconds. Yes or no, is the crack acceptable? If you said no, then you would be correct. ASTM C1840 says that any circumferential crack greater than a tenth of an inch should be repaired. So because it's not acceptable, we need to look at a possible repair or how we can address this issue. So what would you recommend? So we know a couple of things about this. Number one, circumferential cracks, they're not structural in nature, but it could affect the functionality of the pipe through infiltration or leaking. And this crack is really too large to heal itself through autogenous healing, like we talked about in a previous webinar. So we're going to need to seal this thing manually. Now, luckily, we are close to the catch basin, right? We're only within a few feet. So we could probably enter the catch basin, enter into that structure, and seal it by hand. All right, we could use some type of either crack sealant or a non-shrink grout or something that should do the trick there. So this case, just like the crack, is sealed. All right, so as you're watching this next video, you notice that something doesn't look quite right at the bell and spigot joint. So let's take a look at this video.
See multiple cracks coming off this joint.
All right, let's record our observations here. Again, 18-inch reinforced concrete pipe. We see a spiral crack near the joint. Now, if we're orienting the pipe and we're looking at it with 12 o'clock being the top of the pipe and 6 o'clock being the bottom of the pipe, right? This runs from what I could tell approximately 4 o'clock to 8 o'clock in an orientation there. This crack also looks to be less than 5/100ths of an inch, so it's relatively small, but slightly more than a hairline. So is this crack acceptable? Take a couple of seconds, think about it. What do you think? Is it acceptable? All right, if you said yes, you would be correct. Now, this crack doesn't seem to be structural, and it is small enough that it should heal itself because it's less than 5/100ths of an inch. So that shouldn't be an issue. We should be okay there. But again, why did it crack in the first place? What is causing this crack? I'm going to give you a couple of seconds to think about it and look at what's going on with it here and think about what could be causing this crack. Now, it's kind of a trick question because there's really not one correct answer. It really could be a number of things. So let's look at when broken bells and spigots typically occur and what's going on here. Now, one of the reasons that they typically occur is that the pipe is homed at an angle. So as we're bringing that pipe in, if you think about that pipe coming in at an angle, that can put severe stress on the bottom of that pipe, on that spigot as it comes into that bell. So that could be one reason. Another thing that we see quite often that is a really bad practice, and we got to try to fix this so that it doesn't happen. But a lot of times when we home that pipe and we look and we're getting our grades and our alignment, we're looking at it, we notice, oh my gosh, this pipe is not at grade. We need to take some material out, or we need to bring some more material in underneath the pipe. And so the standard practice is to remove the pipe, put the material in, or remove the material as necessary, and then rehome the pipe. Now, what we'll sometimes see with contractors is if they're in a hurry, they'll just grab the bell end of the pipe that's already homed with the bucket and lift it up, and then either put material underneath it or dig a little bit of material out of it. Now, this is a real big problem because once that pipe's homed, it really doesn't have a whole lot of give that it can move. So by lifting that pipe up to either put material underneath it or take material out, you're causing extreme stress and tension on that joint. And what we'll typically see is you'll pop a bell or you'll pop a spigot. And that's probably what happened in this case. Another one that we see, we don't necessarily see it as much with the newer gaskets that we're using, but you used to see it a lot with like O-ring gaskets, but it could still happen if you have material in like, say, a pre-lubricated gasket. If there's too much of the lubrication in one area, maybe the gasket is thicker in one spot. So if you don't equalize it and make sure that it's all even around the whole pipe, you could have too much material in one location of the gasket so that the gasket's thicker in one spot. And if that's the case, as you're homing that pipe, it could cause just enough pressure and stress to pop that bell or that spigot out. And so those are some of the things that typically cause bells and spigots to pop off and break there. And it looks like this bell was definitely rung. All right, let's take a look at another video, shall we?
Looks like just a little hairline crack right there.
All right, let's record our observations here. This is another piece of 18-inch reinforced concrete pipe. If you can't tell, we get a lot of videos with 18-inch RCP. That's probably our most common our most common size of pipe. So we see that quite a bit. What we're noticing is that there's a longitudinal crack and it goes from one pipe to the next across the joint. And we also notice if you saw as the camera spun, it's actually on multiple locations on the pipe, right? So it's in a couple of different spots, but in this piece of pipe. So that's kind of interesting and curious there. The cracks themselves do look to be minor or hairline, so that's good. They're not too severe and too serious, but we still need to look at it and address it. One thing that I did want to point out that I noticed as I pulled the plans for this project as I was doing my research, and I'll just let you in on it because we don't have the time to do that, but the cover over this pipe is relatively minimal, right? So it's a pretty shallow buried pipe. And one thing that we also know, some of our observations, this is just from knowing what we know about pipe, that longitudinal cracks are typically structural in nature. Where circumferential cracks are not structural, longitudinal cracks do show that there might be an issue with loading and structural. Okay, so is the crack acceptable? It's a good question. Right, one that we get a lot is any longitudinal crack acceptable? We've already kind of talked about circumferential cracks and the level of acceptability there, but is this acceptable with a longitudinal crack? If you said yes, you'd be correct. Now, even though the crack is considered structural because it's a longitudinal crack, it's still hairline. So it's still about 1/100 of an inch, which is acceptable based on the specifications. So again, taking it that next step further, what's causing this crack? What is the reason here? Give you a second to think about it. What do you think is causing that crack? If you said that the pipe is seeing too much loading, you'd be correct. Because we observed that it's shallow cover, and it's an isolated incident in the pipe. It isn't happening everywhere. It's not a crack that runs from one end of the pipe to the whole other. It's a pretty isolated incident on this pipe run. It means that this likely occurred during construction. It usually when you have a lot of load during construction, you'll see an initial cracking, and then once you take that heavy construction load off of it, the pipe goes back to a hairline crack, and it kind of is resilient that way, and it shouldn't be an issue. So we're probably getting some where we didn't put enough cover over the pipe during construction. So they're running heavy equipment over it with a shallow cover. And so that can be a pretty significant issue to cause some of this minor cracking during construction. And they say that heavy is the head that wears the crown. Heavier is the construction load on this pipe. I'm sorry, what was that you said? Oh, you'd like to watch yet another video? Well, friend, I have some very good news for you.
Just some surface cracks here. You kind of see a little sweat in from the water. Just a little ones just heading back towards that last joint.
Okay, let's record some observations. 18-inch RCP. There are multiple cracks near the joint. The cracks are on the side of the pipe, not the top and bottom, which we usually see. Interesting. The joints and the cracks are filled with this white material there. That's kind of interesting as well. Keep that in mind. So, are the cracks acceptable? Give you a few seconds to answer, and let me know what you think. Are the cracks acceptable? Well, this one's kind of a tough one, isn't it? Multiple cracks, a lot of them, on the side of the pipe. Interesting. Are they acceptable? If you said yes, you would be correct. Now, the cracks have already gone through autogenous healing. That's what you're seeing. That's that white effervescent material that's in there. You're seeing that limestone that's coming in, that calcium carbonate that's filling those cracks. And we talked about autogenous healing in a previous presentation, but that's what you're seeing here. It's that really cool natural phenomenon that happens in concrete. Because they've already gone through autogenous healing, these are acceptable per ASTM C1840. If you also remember in a previous webinar, when we recracked the pipe, we found that it was actually stronger when we cracked it a second time. So really cool process there, but these are acceptable. So what caused the crack? All right, think about it for a second here. What do you think caused it? Now, as I mentioned before, it was really curious that it happened on the side of the pipe, right? Usually when you see heavy loading on a pipe, you're going to see cracking in the top and bottom. And if you see it on the side, usually you don't see it on the side unless you see it on the top and bottom as well. It's pretty rare to see it just on one side. So that's the first thing that jumps out at me as I'm going through my my little crime scene investigation here. What is causing this crack on the side of the pipe? The pattern is also kind of interesting where you have multiple cracks, a kind of spiral cracking here, multiple longitudinal and circumferential. It's just really an interesting layout here. Typically, when you see that, it signifies that there was some type of impact to the pipe. So if a pipe was dropped or if it was hit by something, you'll usually see cracking like this. So if you said impacted by something during construction, you'd be correct. Now, my best guess based on this is that the bucket of a backhoe or something hit the side of the pipe after it was already in the trench. What we'll sometimes see is if a contractor's trying to get the pipe realigned after it's already homed, they'll kind of take the bucket and try to move the pipe just a little bit. Again, not something we really recommend doing. It's not the best practice because, these pipes, as you get them in the ground and as they're homed, we don't want to move them too much. So if you have to, pull it out, fix the alignment, and then put it back in and home it. But sometimes if you're really careful and soft with it, sometimes it won't do too much damage to it. Again, not recommended, but depending on how much you do. Now, if a contractor is getting a little bit overzealous and they start banging it on the side with the backhoe to try to move it a little bit to get it back into alignment, that could be a major issue. That's probably, based on what I'm seeing in this video, that's my best guess, is that you're seeing like a backhoe, the bucket just smash into the side of it to try to get it on alignment, or maybe it was an accident and they swung and hit the pipe and on accident. So there's a lot that can happen, but that's kind of my best guess there. Some say strike while the iron's hot, but others say strike while the pipe is in the trench. Another one.
See, there is a gasket that's rolled out of this joint.
All right, what do we observe here? Okay, this is a 24-inch reinforced concrete pipe. We're seeing a joint gap around 1/2 inch. Kind of a big joint gap, really, if you think about it. Pretty big. Probably exceeds manufacturer's recommendations, depending on the size of pipe and the manufacturer. We're also seeing a gasket exposed in the joint. Uh-oh. Exposed gasket. Okay, so is this joint acceptable? Well, I'll give you a few seconds to answer. If you said no, I'd agree with you. This joint is no longer functional. It's not going to serve its functional purpose because when you have an exposed gasket, it's really not able to seal. I mean, in extremely rare conditions, you might have enough pressure on the pipe that it could create a seal, but I mean, that's very rare. So if you see an exposed gasket in a joint or one that's kind of sticking out into the pipe, it's definitely not going to allow a seal around that joint. And so it's no longer watertight. So that's a problem, right? It isn't a structural issue, so it's not really going to affect the long-term viability of that pipe, but it's not going to function in its intended purpose. So that could be a problem. So because it's not acceptable, we got to look at how should we fix it? What What do we do? What do we do to fix that? What do you think? You know what? I'd agree with that. The gasket, because it's protruding out into the pipe, sometimes the gasket's just in the joint. This one, you can actually see it sticking out as we came into that view. You could actually see it sticking out. So I kind of have an issue with that, with the pipe sticking out into the or the gasket sticking out into the pipe. So if possible, if you can get into there and cut it, that would be preferred. If you have a gasket that's kind of hanging into the pipe, you should cut it and then go in and seal it. Sometimes in like a smaller diameter pipe, it's going to be really hard to get in there to cut it and to seal it. So you might have to do like a grout sleeve or an injection grout around it just to seal it up and get that. I don't know. That's a tough one with these smaller diameters with these exposed gaskets. So because these ones are so difficult to fix and they become such a pain in the neck to fix them, this is really important that we talk about this next question. That is, what might cause this? Because these are so, like I say, these are just kind of a pain, and it's not like a crack that can heal itself. This is kind of an issue that it's not going to be able to serve its function. So what's causing this exposed gasket? Typically, this occurs when the contractor places the gasket on the pipe improperly. It can also happen when the contractor either rehomes or realigns the pipe after it's in place. So basically what happens is, think about that gasket gets put into place as we home it, right? So it's now pressed between the annular space of the spigot and the bell. So it's held into place there. So once it's in place, it's good and tight in there. But if you start pulling it out at an angle, right, to rehome it, or if they're trying to realign it, so they're moving that pipe after it's already homed and the gasket's touching the gasket that was originally on the spigot end, if it's touching that bell end and they're pulling this pipe in and out or trying to rehome it or realign it, that gasket's going to grab on the edge and kind of start sliding around and moving. And we've seen that before, where it has enough tension, enough friction that you pull it out and put it back in, and that gasket now is slid around and it slips a little bit. Now this one's interesting because it's on the side of the pipe. If you notice, as we were coming into the pipe, this gasket was on the side. So I would say in this one, sometimes we'll see them in the bottom or in the top, and that's pretty obvious that they did a regrading of the pipe and kind of pulled it in and out. But this one, where it's on the side, it makes me think that they probably realigned it. So they wanted to, it wasn't maybe on alignment. So they, instead of, they instead of pulling it out straight, they just kind of pulled it to the side and pulled it out, and were pushing it in to kind of get it in and out there. And that becomes a problem, because then that gasket can slip and get exposed there. Yeah, you might say that the truth about this gasket is getting exposed. I think you know what's coming by now. It's it's one more video. All right. Let's look at our observations. Yeah. That one is a problem. All right, let's look at some of the things that we got going on here, because I know there's a lot. So let's look at them all here. Number one, multiple cracks larger than 1/10 of an inch. That's a problem. You probably saw the exposed steel, also a problem. There was a bit of a circumferential offset. So as this pipe cracked and was damaged, it actually offset and moved up and down. So yeah, that is quite an issue. There is definitely some structural issues here that we need to look at. So I don't even think I need to ask this next question. Is this acceptable? What do you think? I'll give you 1 second to answer. And if you said anything other than definitely not, you would be incorrect. So this is definitely not acceptable. We need to look at some issues here, and we're definitely going to have to fix this thing. So how should we fix it? Well, I guess there's a number of options. There's really not one good fix that we could do. It all kind of depends on a lot of different things, and let's talk about some of the repair options in this case. So one option would be a grout sleeve or multiple grout sleeves. This is a pretty big break. It's a pretty big issue here, and a grout sleeve is really only good if it's at like one crack or something that you can fit within the width of the sleeve. So the sleeves are different sizes. Some of these grout sleeves, as you expand them and you inject the grout into them, some of them can have some structural benefits to the pipe, but it also could potentially change the hydraulics and decrease the internal diameter. So you may not get the flow rate that you needed. So there are some issues with grout sleeves. Whether you're using one or putting two together, those are some things that you can look at. Another one would be like a CIPP structural liner. There's CIPP liners that are just liners that have, like, if the pipe has some holes and it's got some leaking, you could put a liner in. But there are some that are thick enough that could provide some structural element to it. And because we have some structural issues, that might be a viable option. Again, the thicker your liner, the more it's going to decrease your internal diameter, and so you could have some reduced flow rates and some issues there as well. And lastly, another option would be maybe to just remove and replace that section of pipe if it becomes that big of an issue. I've seen issues where people will remove and excavate around it and put some type of liner inside, like a thin liner, just to seal it, and then pour like a closure pour of concrete around it if they don't want to remove the whole thing. But really, when you have an issue that's this severe, you're definitely going to have to do some level of work to fix it. So again, I want to look at, what could cause this? What could have caused something this catastrophic? Now, whenever I see something like this, it's pretty clear that it was a pretty major issue and a catastrophic event happened during construction. So I would say it was impact during or sometimes after construction. Now, I've seen pipes that have been in the ground for a while. I've seen them get hit by, whether it's driving a signpost in, or, someone didn't know the pipe was there and they drive like those Jersey barriers have the stakes that go in them, these metal stakes that I've seen contractors drive those metal stakes in to anchor in the Jersey barriers. And if it's a shallow bury pipe, sometimes they'll hit a pipe and damage it. This particular case, I do know what happened in this one, and it was kind of a curious one, kind of an interesting thing that happened. It did happen during construction, so it wasn't after construction, it was during construction. And this pipe was a really shallow pipe, and so there wasn't a whole lot of cover over it. And the contractor was actually grading right above this pipe. And as it came through, the blade of the grader actually caught the bell that was sticking up out of the ground a little bit, because that bell sticks up a couple extra inches, and the grader blade grabbed that bell. And if you think about the weight of a grader and how heavy it is, and as it's coming in and you're pushing all of this force as you're grading, and that blade of the grader grabs that bell, and it just creates this massive amount of torque and pressure on the pipe, so that it just shears and causes incredible damage to this pipe, and it causes the break that we see in this video. It was pretty remarkable. Kind of a freak deal. You don't see it very often, but when you do see an issue like this, it's quite an issue. So the unfortunate thing is, a lot of times you don't catch this until after you've graded out, sometimes you've even paved. So to come back in after the fact and try to, do a remove and replace sometimes is a problem. So, we always want to look at other options and other remedies that we can look at. But this one was kind of an unfortunate deal. It is safe to say, however, that this pipe didn't make the grade. All right, we're running low on time here. Unfortunately, we don't have time to look at every single situation or every scenario. So this has been kind of a good cross section of examples that we could look at when we look at pipes and get us kind of started here. But I would be remiss if we didn't show some flexible pipe and discuss some of the issues surrounding them and what we can do and what some of the, what causes it and what we can do to fix it. So this is a pipe that you can see non-elliptical deflection, where you've got some major issues on the left-hand side of that pipe. What causes this would be lack of compaction on the sides. This is a flexible HDPE or thermoplastic pipe. Not adequate compaction on the sides to keep it into place, but really heavy loading on that top left side of that pipe. Heavy loading can cause it to come in and have a non-elliptical deflection like that. There's really no good repair method for this. There's really no option other than remove it and replace it. Once you have this non-elliptical deflection, that is in failure mode, and you got to rip it out and replace it. So while there are some things you can do with concrete pipe to repair it, for this flexible pipe, an issue like this, it's remove and replace. It's the only option. All right, what about this one? Again, this is another thermoplastic pipe. This is an HDPE pipe. You could see the crazing on the side, that white along the right-hand side. That shows that we've got kind of a weak point where the pipe is starting to deflect and bend. You notice downstream in the pipe, it's got an obstruction there where the pipe is actually collapsing, already starting to collapse in on itself. That could be because they either loaded too much on top of it there, they struck it with something, maybe a big boulder was put in the trench and they started compacting it against the flexible pipe that isn't strong enough to withstand that. So these are all issues. There's, again, really no good repair method other than remove and replace. That would be the recommendation. Cut this section of pipe from where this white thing on the side is happening, where it's starting to craze, because that's showing that the pipe is weakened in that spot. So we got to remove that whole section of pipe and replace it. All right. This one is a corrugated metal pipe. You can see the corrugations there. This pipe, you're starting to see some damage there on the side, but it's definitely buckled, and it's a major issue there where it's buckled. It's starting to fill in with debris and sediment there. So it's just a major issue there. When you start seeing buckling like that, that pipe is not going to withstand the structural load on top of it. It's not going to be able to hold the structure and the load. So that one, again, you guessed it. The recommendation is to remove and replace this section of pipe. So as I was walking through a box culvert one time, I saw this pipe that was tied into the box culvert. It came into it, and I noticed a few different things to it. It was pretty interesting. On this pipe, number one, if you look down it, you've got kind of a sag or a belly in the pipe there. But this is a thermoplastic pipe, a black HDPE pipe. So it's that black plastic. Couple of things that I noticed about this. Number one, this pipe was it was actually smooth lined or flat on the inside at one point. So you look at it and it actually looks almost like corrugated metal pipe because of the corrugations. But that pipe, when it was first installed, was flat on the inside there. And this is a phenomenon that's known as corrugation creep that we see a lot in these thermoplastic pipes that have these corrugations on the outside of them. As you start compacting against them, because we know we've got to compact it pretty significantly to be able to get the structural strength that we need. In a previous webinar, we talked about, 4 to 6 inch lifts compacted at 95%. So as you're compacting against this pipe to make sure that we've got that structure on the side, you start seeing the corrugations on the outside going along the path of least resistance, which is that thin, smooth wall on the inside. So the corrugations on the outside, as you compact against them, they actually start to creep inside the pipe. Now, the issue with this is that a lot of times hydraulically, as we design a pipe, we have a very specific flow rate that we have in mind that we model and look at this pipe to make sure it can meet that. If we're using a Manning's N of, say, a 0.012, that's going to give us a roughness coefficient that allows a certain amount of water through. But when we start seeing this corrugation growth, and as it goes in here and we're starting to see more of that creep, it actually models itself more, less like a smooth lined pipe, like a smooth interior pipe, like a concrete pipe, and it's more like a corrugated metal pipe, which is sometimes almost double the Manning's N as a smooth pipe, which would mean that we can't get as much water through there. So hydraulically and functionally, this could have major impacts on our pipe. The other thing that I notice about this is the deflection. We know that 5% deflection is acceptable. We talked about that in a previous webinar about what's acceptable. And you can notice there that even just by looking at it, we don't have a mandrel, but by looking at it, we could tell that that pipe is deflected well beyond 5%. If you say, well, it looks kind of close to 5%, I think it'll be okay. When I measured it, I went and looked, it was actually closer to 15 to 20%. So yeah, pretty significant, 3 to 4 times higher than the allowable deflection. This pipe is deflected. So it's no longer structurally sound. It's beyond what it was designed for and what it was intended to do. So, again, there's really only one option for this pipe, and that is remove and replace. Well, I want to thank you for taking the time to watch this webinar today. After speaking about the theory for the last couple of webinars, it was good to take a look at some real-world examples, and I hope that you had as much fun as me. So congratulations, Detective. Good luck on your next case. Now, remember, if there's one thing you take from this webinar, it is that the most important thing that we talked about today, and that is, under no circumstances should you ever be allowed to For more information about this topic or any Oldcastle products discussed in this presentation, please email me at jason.allen@oldcastle.com or visit oldcastleinfrastructure.com.